Okay, so I know I don't have a title up here. I will in a few minutes. It'll be solving logarithms or solving logarithmic equations in case you must have one here. But I did want to show you something that I think is actually quite funny. And that is that I found this site that tells you how to label semi-logarithmic graph paper. So it says that you would start by going 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then you would go up by the 200s, then you would go up by the thousands, and so on. So you would end up with something, depending on where you started, you would end up with something like this. Where is this funny? I think it's hilarious that this is called msu.edu, so MSU Education. I think that's hilarious because, of course, we know what MSU stands for, and sometimes that's what logarithms feels like. So, haha, that's my funny for the day. All right, back to the note. This part of the note is quite simple, but it feels like memorization. You need to be able to move between logarithmic form and exponential form quite fluidly or fluently, like without thinking too hard about it. So I've got a zillion questions here, bit of an exaggeration. All we have to do is we have to change one into the other or vice versa. So as you can see, logarithmic form up to where you can see on the chart so far has the word logarithm in it, and exponential form uses exponents. So that's kind of implied. And hopefully you remember what logarithms actually mean, and that is that this says how many 2's does it take to make a 16, use an exponent, and it's 2 to the 4 is equal to 16, and that's actually the answer. And then you have this one. So this says 7 to the 0 equals 1. And these are all, I don't know, checkable. I mean, you could plug this into your calculator and make sure it actually worked. So you have, I think, 6 different arrangements of these numbers. You have to find the one that works. Here's another one. Yes, I'm missing 2. So that's 3 to the exponent 4 really is 81. And then this one. So if I go back, even though there's a bunch more questions, if I go backwards, that means I have to take the base on the exponent and use it as the base on the logarithm. I was trying to create 1/4 using its power. So you have to be able to go backwards and forwards mathematically correctly, and this one isn't necessarily checkable until I give you the rule, which I think is part of the next lesson. So let's try it again here. The base is the base. The exponent is the answer, because remember this means power. And then the 8 sits here. So this says 3 2's multiplied together equals 8. See where we're going with this? Letters, where you can't check your work. That's the end, so we're okay there. So I find it way easier to go in this direction. So log, I'm writing what I'm saying. Log base 4 of 16 is equal to 2 means that it takes 4 times 4, 2 of them, to make 16. A little bit more difficult, a little bit bulkier, I guess. 2 to the exponent negative 2 is equal to 1/4. So what exponent on a 2 gives us 1/4? That exponent would be negative 2. And then working backwards. So this one actually has 2 possible answers in my world, as does this, and I'll show you them in a second. First one would be log base 25. Yes, you can have a huge base. And then we were working with a 5 and our exponent was a half. Do you see another way to write that? Do you see another way to write this? As in, you could have been given this and still been expected to write this piece of information. So both of these create our logarithmic equation. Next one, log base 10 of 1 equals 0. The 10 is optional. Then, can you do it generally speaking? So can you do it without any numbers to check your work? So you have to follow the pattern and, did it again, thinking and writing, you have to follow the pattern to make yourself an exponential equation. And you have to follow the pattern to take an exponential equation and turn it back into a logarithmic equation. So I find it very handy to know that the base is the base. And then the other letters or numbers fit in where they can. So I think that this particular note, the solving logarithmic equations, some of it is quite easy, some of it is quite difficult. It depends on your knowledge of numbers, as usual. Welcome to math class. So the first thing I want you to notice about the 6, I think, logarithmic equations that we have is every single one of our logarithmic equations has the word logarithm in it. Here's this one. Here's this one. Here's this one. Those 3 are pretty tiny. Oh, that's got lots of logarithms in an equation. Lots of logarithms, not quite as many, in an equation. Ditto in an equation. So, eventually I will ask you, can you notice a difference between any of these questions? And hopefully your answer will be yes, because there is. But let's start with these little guys, which often give more trouble than you think they will. So, this question right here. Some of you might want to take the opportunity to change from logarithmic form to exponential form. Sometimes that's handy. Sometimes, kind of like the test for the Wayne-Gretzky questions where you split the question in half, factor, and see if the brackets are the same. Sometimes that works, sometimes it doesn't. Sometimes this works, sometimes this doesn't. So I'm going to take this logarithmic equation and turn it into an exponential equation, like we did here, and see if it's useful. Remember, I also have this eraser thing. So it's 3, as in this 3, to the exponent 3, as in this one, equals x. And, oh, I'm kind of almost done. I mean, the x is all by itself. It says solve for x. So that means as long as I can figure out what 3 to the 3 is, I'm done. And hopefully you can figure out that 3 to the 3 is 27, the end. Now I will come back to all these questions eventually, but I'll wait until page 2 and then come back. So I'm going to try this. 5 to the exponent x is equal to 0.04. I know something special about decimals that maybe you'll remember. So I know that because I've got 2 decimal places, that's 4 over 2 zeros after a 1. And if I reduce that, divide by 4, divide by 4, I can change the look of this decimal and turn it into a fraction, which, believe it or not, is actually easier to deal with. And the reason I think it's easier to deal with it is because I know that 25 is 5 to the 2, but it's on the bottom, so that means it's 5 to the negative 2, And because these are balanced, this is totally illegal, I can not look at them anymore, and I get an answer for x. So that means that if I could plug this into the calculator using my logarithm button, which I can't because it's not a base 10, if I could punch that in, I would get this as a true statement. And we can always check this tomorrow when I show you that last little trick. Last question on this page. I'm going to see if the logarithmic to exponential equations actually works and helps me out. X to the exponent 2 is equal to 64 is changed from logarithmic form to exponential form. And we end up with x is equal to, remember unit 1, plus minus 8. Now we have to come back to all these questions, so don't think we're done right here. I will come back in a minute to talk to you after we deal with a biggie. So I'm going to take a little hand cramp break, and I'd like you guys to take a look at these 3 questions and tell me if there is something that you notice that is either that is different or the same about these questions. So hand cramp time. All right, break time's over. Did you notice what's different about this and what's the same? So maybe you noticed that questions E and F are both base 8 with the logarithms, and D is base 5. That's actually super important, but it's not what I wanted you to notice. So it's not wrong, it's just not what I want to draw your attention to right now. I want to draw your attention to the fact that question D has all its parts having log base the same, as opposed to question E and F, where 2 of them are log base the same, and one of them is just simply a number. It just happens to be the number 1, but it's just simply a number. And then this one's got 2 parts having the same base for logarithms, and the other part is simply a number. So I realize that this one has the number all by itself on the right, and this one does not, but that's not what I want you to look at right now. So what we're going to do is we're going to take a look at D, and then E, and then F, and at some point we'll go back to page 1. Now I think there's a huge difference between these two. Even though you can turn D into a question like E and F, I'm not going to take that approach. If you want to see another version of D, please ask me. I'm happy to mention it. What I do want you to notice is the fact that yes, it has the same basis. So when I look at this left-hand side, I can actually use my law of addition or multiplication to scale this back. I can write this as log base 5 of x multiplied by x minus 1. And then on the other side, I have log base 5 of 2. And the beauty in that is that I've got a log base 5 on both sides of the equal sign, which means I don't have to look at them anymore. I really shouldn't cancel them out, so I'm going to uncancel them in a second. But I don't have to look at them anymore, and instead I can just look at this stuff and this stuff. So I'm going to write down x squared minus x, so I multiplied that out, equals 2. And then I'm going to go back and do what I said I was going to do, which is to remove that. You could not cancel here because you can't cancel 2 for 1. So you have to cancel 1 for 1, or at least ignore 1 for 1. So I'm hoping that you look at question D and you see that there's an x squared, and you see that it does not equal 0. So our job is to make it equal 0 so we can do factoring, because I told you factoring was in every unit. So I hope you look at this and you think to yourself, I could use the quadratic formula, or it's a simple trinomial that's factorable. So 2 numbers that multiply to be 2, that at the same time add or subtract to be -1. So we have those guys. And then I'm going to dig out the green pen because I like to be consistent. And I come out with an answer. So x equals 2, x equals negative 1/2. And if you're sitting there wondering why did she write it like that, this is where I have to go back to page 1. So the thing is, you can have negative answers, but you can't take the logarithm of negative numbers. So if I take 2 and I insert it back in behind this log as its operator, that little bubble of yellow stays positive. And if I put 2 into that little bubble, that will be 2 minus 1, which is 1, and 1 is positive, and positives, for lack of a better phrase, are loggable. That means this is a totally acceptable answer. Now let's check this one. If I take negative 1 and I put it back into this little yellow bubble, I will be taking the log of a negative number, which is completely illegal. You can try that on your calculator as much as you want. It won't let you do it. And the reason is because of the graphs that were part of the graphing note. So you don't end up with any negative x values, so you can't take the log of a negative number. So that means that you did all this work to come out with 2 answers and only one of them works. It's this guy. Unfortunately, it could have been either one of them. It could have been none of them and you end up with no solution, or both of them could have worked. So you have lots and lots of options of what could happen. I do want you to know that the name of this one, which I will cross out because it's not acceptable, is the word extraneous. And I have to say it that way so I spell it properly. So it's extraneous, meaning it's you did all this work to get extra and it doesn't even work out. Now let's go back to page 1. We have to make sure that we check for this kind of stuff in all these questions. So 27. This is where the x is. 27 is just fine because 27 is positive. Next question. Oh, that's just a number. That doesn't worry us at all, so that answer is just totally acceptable. This is fine. What's in question is that. And you are also not allowed to have a negative base. So I didn't put the therefore symbol purposely beside that. And the reason is because even though mathematically we come out with a positive or negative 8 being squared to create 64, we're only allowed to have the answer 8 as part of the logarithmic equation. So every single one of these questions needs what I call a mental check. So you have to do a little tiny check mentally, or you can write it down if you choose. But you have to do some sort of check at the very end to make sure that your answers can actually be your answers. So I'm going to move this just for the time being, and I'm going to make a little note saying that you need to mentally check logarithmic equations. You can only take the logarithm of positive numbers. Do you know what that means? That means when you try to take the logarithm of a negative number, when you try to take the logarithm of a negative number, it's not allowed. When you try to take the logarithm of a 0, it's not allowed because you're only allowed to take the logarithm of positive numbers. So that is literal. Leaving F, going on to E, which for me in my eyes is a totally different kind of question. So for me and my eyes, I look at this question and I say, oh, part of these are logarithms and part of it isn't. So my first approach is to take this question and write all the logarithms on one side of the equal sign and all the non-logarithms on the other side of the equal sign. So what that means is that this log base 8 of x minus 4, and if I can use my tablet and make this 8 appear slightly below and this appear on ground level, then you can do it on paper. This log base 8 of x plus 3 will be positive on the left. And then I'm going to leave the 1, or whatever digit I give you that is not attached to a logarithm, by itself. Please notice that these are both log base 8, and I'm adding, which means that I can scale it back to multiplying. Now this is a little bit different than the one that was above. And the reason I say it's a little bit different is the one above, don't know if you remember this, but I said you don't have to look at the log base 5 because there's 1 on each side, and you can kind of imagine that they're canceling out. They don't cancel out, they're just balanced so you can ignore them. But that's not the case in question E. In question E, you've got a log base 8 on the left, and you don't have 1 on the right. So what you are allowed to do is take this logarithmic equation, and turn it into exponential form so that you lose the logarithm. And what that looks like in this question, and maybe you're seeing all the rules fitting together or panicking you right now, and that's what makes logarithms a little bit difficult, is 8 to the 1. So this is your base, this is your exponent, equals, and I'm just going to take a sec to FOIL this out. So x squared plus 3x minus 4x minus 12. So you can't just move the 1 over. You have to actually convert it. And then I still got an x squared, so that means that I'm going to bring everything over and make it equal 0. So I'm putting the 0 on the left because I like my x squared being a positive value. So 8 to the 1 is 8, so I'm just going to subtract it over here, and I'm going to collect like terms. So negative 1x, negative 20, and you can use the quadratic formula, or you can factor if it's factorable. So another simple trinomial. Aren't I nice? So two numbers that multiply to be 20. That can make negative 1. Green pen. Possible answers. Now, it could be that both of these are just fine. It could be that one of them is not fine. It could be that both of them are not fine. This one is not out of the question yet just because it's negative. This one has to be tested mentally or written before you annihilate it from your question. So let's focus on 5 first of all. If you put 5 back into this bracket, which has logarithm base 8 of 5 minus 4 is 1, 1 is positive, so far so good. 5 plus 3 is 8, 8 is positive, so far so good. Now let's focus, so this guy's just fine. Happy face, whatever you want to use. Negative 4, not gone yet. Negative 4, subtract this 4, is negative 8. Negative 8 is negative. We're not allowed to log negatives or 0. So now 4 is gone. Sorry, now negative 4 is gone. That is not allowed because when we checked it, it created a negative in the bracket after it was being logged. And once it's garbage forever. So it doesn't matter. You don't have to keep checking the other one. Once it's not acceptable. It's not acceptable in any part of the question. So you can write down extraneous if you want to there, but I'm going to put my triple dot therefore right here to say this is the only answer, and because this gets a bit messy, I'm going to put a circle around it so you can see it. So we've got one last logarithmic equation question to solve. This is one of my favorite kinds of questions. Testing your math vision. I'm just going to put it on a new page because this is quite painful for me after all that moving around. So this is more like E than it is like like D, because D has all parts log base 5. E had one part that wasn't log base 8. This has one part that isn't log base. But if you can see, compared to E, step 1 is done for us. We have all the logs on one side, all the non-logs on the other. This one's set up a little bit better. And I'm going to show you a wrong answer, so I'm going to write this in, I don't know, green because it's optional. Can you see what's wrong with this? I'm being purposely messy. Can you see what's wrong with that? It is very wrong. I mean, great. It looks like you can use the rules. I mean, it doesn't have the number out front. It doesn't have the number out front. So you can use either the law of division or the law of subtraction, depending on what you want to call it, or the law of addition or the law of multiplication. The problem is that this is a subtraction sign, and I just did the law of addition / multiplication. You have to watch your laws. It's not always what you want it to be. So I'm going to erase that and put down the right version, which is log base 8 of, just for kicks, square bracket, x divided by x minus 1. And no, you are not allowed to cross that out because this is in the way. And now we get to do our logarithmic form into exponential form. So 8 is the base to the exponent 1 is equal to x over x minus 1. That's 8 equals x over x minus 1. Put that over 1 so that if you need the visual for cross multiplying, you can. So I'm going to cross in this direction first. So 8 times x, 8 times 1 equals, cross in the other direction next, 1 times x. X is on one side of the equal sign, numbers on the other. Make it look pretty. So collect like terms and get the x by itself. So law of division is actually potentially easier than law of multiplication. So you get x equals 8 over 7. But I don't know whether to put the triple dot there or to cross it out, because we have to check it first, because these were logarithmic equations. So 8 over 7. If I put 8 over 7 in here, 8 over 7 is positive. It's ugly positive, but it's still positive, so I'm good to go. 8 over 7 minus 1 is actually 8 over 7 minus 7 over 7, which is 1 over 7. So this is still positive, which means I get to do that, any form of it, to sum up my work, and I am done. So I know this is pretty right. In your little booklet, these are the logarithmic equations, and there's a handout that is in your supplemental booklet if you're actually with this class. It's part of the Google site if you prefer to look there. There are some boxed questions, okay, and it should be on the bottom part and reverse side, and they should be the logarithmic equations, so all the ones with logarithms in them. So that is that, and we have one more lesson before we hit real life, air quotes, real life applications for this stuff. So, hey, I'm pretty proud of myself. Talk to you soon.